I made another video where I talked about how to use the table E, to go from probabilities or percentages or areas to z-scores. And in this video, I'm going to talk about how to do that using technology, like a graphing calculator or something. How to start with a particular area or a particular proportion or percentage or probability and find the z-score that it goes with. Like if I said, what's the z-score so that the area under the standard normal curve to the left of that z is 0.8810, the answer would be that z is 1.18. So here's how you would find that with a graphing calculator. For what z value is the area to the left of that z equal to 0.378? The graphing calculator function that we use for this is called inv_norm, which stands for the inverse normal distribution. So here's how we use that. Go to the distributions menu by pressing second and then the button that says DISTR above it. And what we want is number 3 on the list, inv_norm. So select that. And if it just shows up like this, then all we have to do is put in the number 0.378. And it gives us the answer, which is about negative 0.31. On some other calculators, when we go to the distributions menu and select inv_norm, this is what comes up, a little screen like this. So where it says area, that's where we would put in the number 0.378. And if we're dealing with z-scores, make sure your mu is set to 0 and your sigma is set to 1. And then just go down to paste, hit enter, and hit enter again, and the answer shows up, negative 0.31. Here's how you would do this if you were using Desmos, the Desmos app. So go to Functions, select Normal Dist. If you weren't already in the Dist menu, you'd have to get there first. So when you push Functions, you got to go to Dist and then select Normal Dist. Now this will show up here. I'm going to click on the dot, and then I'm going to go back to the Functions menu and select Inverse CDF. And now, inside that second set of parentheses, I'm going to put my number, which was 0.378. And then what shows up in this little box, that is the answer. That's the z that I was looking for. It's about negative 0.31. And if you're using this website, make sure you've selected normal distribution and you have 0 for the mean and 1 for the standard deviation. And we're going to be over here on the inverse probability. So we want this first one. The probability of x being less than question mark equals, so I'm going to put in the number 0.378 and then go down here, make sure you've got this selected, and go down here and click on calculate, and it gives us the answer in red here, negative 0.31. And then it shows it on the graph here. So right about here is where z would be negative 0.31, and then the shaded region is about 37.8% of the whole thing. So here's another one to try. For what z value is the area to the left of that z equal to 0.67? Try doing this on your calculator or your app or whatever. See if you get the answer 0.44 or something really close to that rounds to 0.44. Now what about something like this? For what z value is the area to the right of that z equal to 0.085. If you watched my other video about how to do this using the table, you know that for the area to the right, the first thing we have to do is subtract that area from 1. The total area is 1. If we subtract off the 0.085 that's over here, then we get the part that's over here, which in this case turns out to be 0.915. And that's what we need to work with. That's what we need to give to the calculator. So we're going to take that 0.915 and put that into the inv norm. So if you're using the graphing calculator, select inv norm and ask it for the inv norm of 0.915. And it gives me approximately 1.37 for the answer. If you're using Desmos, go to the functions, select normal dist, and at the end of that, hit the dot, go back to the functions menu and select inverse CDF and type in 0.915 inside that second set of parentheses. And what shows up in the box there is approximately 1.37. If you're using this, now here we didn't have to do that subtracting. We could just select, well, if we want to, we can go to this first one and actually put in the 0.915 and do it that way. And get our answer that way. But we could have also used the original value, the 0.085 that was over here on the right, and select the second one, the one about the probability of x being greater than question mark, and put that 0.085 in there. Because now we're asking, what is this mystery cutoff point so that the probability of being greater than that, or the area to the right of that, is 0.085. So if we ask for that, select calculate, it shows up over here, and it does give us the answer in red. It's about 1.37. Here's another one you can try if you want to see if you've got the hang of it. For what z-value is the area to the right of that z equal to 0.877? If you're using the calculator or the Desmos, you would subtract that from 1. Then you'd ask your calculator for the inv norm of 0.123, because 1 minus 0.877 is 0.123. And that would give you a z-value that turns out to be negative 1.16 if I round it to 2 places after the decimal point. Now, one last example. This is a little bit trickier, but we can do it. For what positive and negative z-values is the area between them in the middle of the curve equal to 0.10, or 10% of the total area? So here's what we're talking about. We're marking out 10% of the total area right here in the middle. And so that would be the part that's between, well, someplace here and someplace here. The part here on the left is going to be some place where z is negative something. And then over here on the right is where z is positive something. And because of the symmetry, it ought to be the same absolute value, just one negative and one positive. But how do we figure out what those z's are? Now remember, before we go to the table or before we go to the calculator or something like that, we got to have an area that is to the left of the cutoff point. So if we got the middle 10% here, and we're looking for the z's that mark off that middle 10%, if this is 10%, that means there's a total of 90% outside this narrow middle strip here. 45% is over here on this side, and then the other 45% would be over here. So this z right here would be the z that has 45% of the area to the left of it, or 0.4500 if we're looking on the table. So if you go to the table, look for the closest thing you can find to 0.4500. Can't find it exactly, but it's somewhere in between 0.4522 and 0.4483. It's actually a little closer to 0.4483 because that's 17 away instead of 22 away. And that goes with z being negative 0.13. You could also put this into like the graphing calculator. Ask it for inv norm of 0.4500, and it'll give you a z that is pretty close to negative 0.13. So that's the negative z value over here on this side. Now, because of the symmetry, the positive z value over here ought to be positive 0.13. But we could also check because that's the z that has a total area of 55%. The 45% here plus the 10% here. So 0.5500 would be the area to the left of that z. And if we look for that on the table, or we ask the calculator for inv norm of that or something like that, we do get a z of positive 0.13.